In this week, we want to start to discuss the principle of Internetworking. This was the search for the one big uniform network. What we know already is that we have different network technologies, different local area networks. We have interconnected such local area networks to wide area networks by the help of intermediate systems. We have discussed how the routing is organized over these different interconnected systems away to a final goal. And now we have to see how we can use this knowledge, how we can bring it together to see how the Internetworking principle is working. So many different network technologies, they are incompatible. In most cases, incompatible means they use different address formats, different communication protocols. So it's impossible to take the protocol or the format of one technology and only to allow to connect networks of the same character. So when we want to interconnect this incompatible network, we need to think what kind of principle helps us to overcome the different technologies implemented in the different networks and used for intermediate transport between one router to another. Each network technology has its own parameter, its own special media, its own signal types, its own parameters, its own addressing scheme, packet format and all things. And of course, each pros and cons which has the user made the decision exactly to work with this network technology. So in the moment we combine these incompatible networks to each other, and if we want to have the interconnection behave like a uniform network, we need to develop techniques because we cannot work with one of the techniques provided. So the question now is how we can interconnect the different networks and what kind of challenges need to be solved in the moment we want to interconnect networks with different parameters and others. So we have to answer the question, how can the mediation take place between the different network technologies? We have to answer what is the packet format, how to address packets in this interconnection of networks, because each address has only sense in the single network. We have to solve the question how the data packets are routed over the interconnected networks to find its final goal, and how to transport this packet when it is transmitted over different networks with different network technologies. So the calculation of the route, how the routers get the information, how the routing tables are computed, needs to be solved. How to recognize network situations like congestion or overlaid situation, how to recognize such situation, how to avoid them. We have to discuss what happens with transmission errors, how to recognize this, how to handle this, how they can avoid it. So all these questions need to be answered, and the concept which answers all these questions, this is the concept of Internetworking. And the concept of Internetworking, that's the topic of our overall course, this was developed when the engineers designed the worldwide internet. The concept to connect heterogeneous computer networks into a virtually unified communication system. Exactly, this is the Internetworking. And an internet is such an interconnection of multiple heterogeneous physical networks with their own different network technologies into one virtual network. This is the internet, the virtual network. And the most important example of such an internet is the global internet. And the proof of concepts we can see every day when we work and communicate via the internet. What are the basic idea of the internet working? The basic idea is that we allow to have the different networks have their own technology, and we interconnect different networks by means of a router. A router, a translator, which translate the technology, the network technology of one network into the network technology of the other. Because inside the interconnected network, network 1, network 2, we interconnect them here by intermediate systems. And this system translates packages, size, addresses which are valid in one network into those which are valid in another network. In this way, the packets are transported according to this technology through N1, and if the package needs to be sent here to N2, then the router receives this. The router completely understands the technology of N1 and translate this, all the parameters, all what's need to be translated into those parameters that are valid in network N2. To make this possible, a common uniform communication protocol is needed. And this software, which organizes translation and which organizes the solution of all the challenges we mentioned, this is protocol software is called communication protocols, a uniform communication protocol, and this is typically the internet or the internet protocol which works over all the technology bounds of the different networks and allows an interconnected network to appear for the user and for the communication as a seamless communication system as one uniform virtual network. So this is done by software layer below up on the network's technology. So all the connected hosts and all the connected routers, of course, must run the same internet protocol software in such a virtual network. And the most commonly used internet protocol software, this is the TCP/IP protocol suite, or shortly called TCP/IP stack. These are many, many protocols. We will learn this in more detail later. But the TCP protocol and the IP protocol in this family are the most important protocols. So the whole family has received their name from these two protocols. Let's have a look to these transmission systems to the routers. Routers are special computers that establish the communication connection between different networks. Such routers consist, like a usual computer, of a processor, of a storage, of an input-output interface. This input-output interface, these are the network cards. And they need such an input-output interface, such a network card, for each network the router is connected to. So the router needs to understand all the technologies inside the connected physical networks. Now the sole task of the router is to interchange data packages between the different connected networks. Of course, only in that case, if one package from this network should be transmitted into the other network. The router needs, for that reason, to transform the addressing scheme they have to transform the packet formats, they have to do some adaptation so that the features in one network technology are mapped in the best way to the features of the other network. The package should be forwarded. The routers themselves needs to be connected like a normal host to each of the networks it should do such transformation work. So routers are simultaneously part of each network to which they are connected. Here is an example. We have different networks, an ISDN network, an Ethernet network, an ATM network, and here are the intermediate systems, the routers, which transform, if a package from an ISDN network should be transmitted via an ATM network, the router here does all the transformation work. Here is another computer that knows Ethernet technology, that knows ATM technology, and can make this transformation. And in this way, this different physical networks, by means of the intermediate router systems, form together one virtual uniform network.